Hello, a very good morning to you. In the last video, we have discussed about Encoder Decoder GRU Architecture for English to Hindi translation along with the Python code. Let us see the video. So this was the previous video. I have created it. In this video, we have gone through what is the encoder, what is the decoder, how to create its architecture, what is the hidden size, how to provide the input to a encoder, which output and or which hidden size has to be taken, and then how to implement the same with the Python code. We have also seen in that video that how the task where the variable input and the variable output is implemented using RNN, that is a recurrent neural network. In this video, we will see what is the drawback of that model and how we can improve that. So this is a simple diagram which I have plotted on a whiteboard. Uh, if I say that, suppose I have a sentence, I am doing my work and I need to decode it, and the decode is मैं अपना काम कर रहा हूँ. So if I just implement the code which I have implemented in the video, that is encoder decoder architecture for English to Hindi translation, I need to pass the whole hidden state of the final encoder to as the first state of the decoder, first decoder state. But just imagine if I want to predict the word मैं, only I is important. Am doing my work is not important. So the researchers worked on that and developed another state of art which is called as attention modeling, where for predicting a particular output from GRU decoder, only that particular input from encoder GRU is taken into consideration, which is important to predict that one. For example, if I want to predict apna, then it's my is important. I am doing work is not so important, so the high attention is to be given to the word my. So the drawback was that before the implementation of attention based modeling, we have to give the whole input, whole hidden state of the encoder output as to the decoder input, which is not actually needed. To optimize it more, we have to provide only that particular input as the to the decoder, which is really important to predict that output, and that is why we are doing this attention based modeling is there. So, and what are the various steps which are involved to do that? First of all, we will multiply. Now how the attention weights are achieved? So multiply the encoder outputs with a linear matrix. So first one, let's see. So suppose what I say that we have a word. Let's suppose we have a word Yamashiro. Okay, so this is a word Yamashiro. Okay, so how many words it has? 1 2 3 4 5 6 7 8 9, including pad it is 10. So if I am giving a input to a GRU encoder, so what would be the shape? It would be, the shape is 10 comma 1 comma 27. Why 27? Because 26 are the alphabets of English, including pad it becomes a 27. Does this make sense? So again, let's see, 1 2 3 4 5 6 7 8 9. So the total we can say the length of the word is 9 words are there, and we also include in the alphabets the word pad character. So it is 10 words, and the dictionary size becomes equal to the 27, because 26 are the words, including pad character it becomes 1. So if you want to dive into this, I just tell you to please see the previous video where you will get to know how the input and output shapes of encoder and decoder are determined, and what is the basic concept of that. Now if I can look, when I pass this encoder, when I pass the input this encoder cell to the encoder GRU, there are two things which will come into play: hidden state and the output state. So if there are the 10 words, 10 would be the size of the output, 1 comma the hidden size 256. So this would be the shape of the output, and when we talk about the hidden state, we are only taking the finals state, other states are ignored. So 1 comma 1 comma 256 would be the size of the hidden. Okay, this is the final hidden state of the encoder. So I say just hidden state. So this is what output, encoder output. Okay, so two things are taken into consideration while we have to. Now what we say, the first step is to multiply the encoder output, means this one with a matrix. When you multiply with a linear matrix, you will get another matrix, you will get another matrix which would have the size which is equivalent to 10 comma 256. So what is the output from there? So output from first step, from first step is so 10 comma 256. Okay, so why the output is 10 comma 256? Because we have the 9 words, and including the pad we have a 10 words, and the hidden size representation is 256. So when I multiply this encoder output with the linear matrix, and we choose the linear matrix in such a way that it will produce me the output equal to 10 comma 256, where 10 is the length of the word plus 1. Now, so this is the first thing we get it. Now let's see the second. So multiply another linear matrix with 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 final hidden state of encoder. So the final hidden state of encoder is we have seen it is 1 comma 1 comma 256. When we multiply it with the hidden state, and then we keep on, we will reshape it, the output from the second step will also be same. Okay, it will be also 10 comma 256. So after reshaping it, okay, second, how we will reshape it? We will reshape it based on the value length of the words plus 1. Why plus 1? Because one of the place is for the pad, that is a pad character. Okay, so why we need the shape, both shapes are equal in the step 1 and step 2? Because in the step 3 we are going to add them. So now what we add 1 and 2. Then what we will do after addition, we will pass it through a activation function. For example, 10h. If we pass it through the 10h, it will make a size which will be limit between -1 to 1. Then at the final stage, we will also do a linear multiplication with another matrix. So with another matrix, so this matrix will produce a size equal to how much? 10 comma 1. We can say that there are the 10 of the weights and there is a one row. Why 10? Because the number of words are how much? 1 2 3 4 5 6 7 8 9 plus 1 10. So 10 alpha values will be there. So 9 alpha values would be there for what? For these words, and 1 alpha value is for the pad. Okay, now what we will do is that we need to find the alpha weights. So to find the alpha weights, we will take the softmax of step 5. Okay, now from that what we will do is that now actually these are the alpha values or the weights. Now when we multiply these, now what to do next? This is important, what to do next. So now we have the alpha weights. Okay, now these alpha weights have to be multiplied with the encoder output. So to when these weights are multiplied with the encoder output, then we will get only those hidden state input to the decoder input which are really important. So hun कितनी shape बनोगी? So what is the shape that we will get is 1 comma 256. So this is the hidden state from the input, hidden state from the encoder, which will be given to a particular decoder input along with a particular decoder input at any particular time step. Like for example, if I want to predict the word मैं, only the encoder state M will be input along with the input decoder. Okay, now what is the size of the decoder input? Basically it has a size equal to the vocabulary. Now we can't concatenate these values because Hindi vocabulary has a size 1 comma 129, but what is the value which is other value which is passing through the decoder GRU cell? 1 comma 256. So we need to convert this value to the value 1 comma 256. This is achieved with the help we will create an embedding matrix that will do that. What how it will be achieved it that so we just multiply this with a linear matrix. That linear matrix will convert 1 comma 129 into 1 comma 256. So now at a particular time step, total value that we got at the input to a decoder GRU is equal to 1 comma 256 concatenate 1 comma 256. Okay. Okay. So it means from here a thing is concluded that when you want to implement the attention modeling, the GRU decoder cell should have the input size equal to the hidden size square, hidden size multiplied by 2, because if the hidden size is 256 you have to multiply by 2 to get a value 512. So this is the change we got it. Now what happens now if I want to give I want to predict cur, so then only the hidden state corresponding to the word am, which is a input word, will be passed to this GRU decoder cell along with the hidden previous hidden state. We will get the output as the cur, which is in the Hindi. Now the question is that if this is a 9 word, why we are passing the pad character? The importance of pad character is that when we are doing a inference stage, that is the prediction stage, whenever you get the 0 as the output, there you break out of the loop, because 0 means now the pad character has been achieved. Now all the predictions corresponding to the input value has been implemented, and so you can do a break of that. And the pad character alpha values does not have any significance because they are not important, but there may be some weight, but that would be very less. So in short, what we did it in the previous video, we discussed about the encoder decoder GRU cell. We discussed about how to implement it. We also discussed about how to pass the encoder final hidden state as the first hidden state of the decoder GRU cell. And in this video we have improved we have studied the other researchers and their state of art methods, where they have implemented attention based modeling to okay. And we have seen that with the help of this attention based modeling, only that words their hidden state will be used at the decoder input, which are really significant using the alphabets. Then we have seen how do we have calculated the alphabets. We have calculated the alphabets by first of all multiplying the encoder outputs with a linear matrix, multiplying the another linear matrix with the final state of the encoder. Then we have adding 1 and 2, provided that we get the same shape from the step 1 or not. If you are not getting the same shape, try to make the shape same. Okay, then we did a activation function on that. After that there is a linear multiplication with another matrix which is called attention matrix, that will provide me the attention weights or alpha values. Just I name it a Greek word alpha, you can name it as a Greek word lambda, it's your choice. Then do a softmax, because the softmax will provide me the alpha weights. After that we will feed these alpha values. This is alpha values means the linear combination of alpha values with the encoder output as a along with the input of the decoder GRU cell, provided that the shape of this value as well as the encoder decoder input would be same. To make it same, we will change the shape by creating another matrix called embedding matrix. You can name it anyhow. We have also seen that if we can say what is the overall decoder input now to a decoder GRU cell, it is equal to 1,512. It is double the size of hidden, so we have to create the decoder GRU cell which is equal to hidden size multiplied by 2. Okay, so you can again, I just suggest to you that along with that you can also have a look at this answer where I have mentioned that what is the difference between a LSTM and GRU. Like I told in the video that a GRU use a hidden state as well as the output state, but if I am using the LSTM, we will also look for the cell state also. So you can also implement this code. And again I say that fortunately this is one of the trending answer in the Quora. Thanks for all the upvotes that people have provided me. This completes my this video. Hope you liked it. You can also ask the question in the comment section if you like that. This is a little tough because this video involves a lot of mathematics, but the core concept of this video is that we can improve the prediction, we can increase the accuracy. Like now when I say we have a attention weights. Okay, because in the previous video we have our model as model.pt, but now the new model is the model attention.pt. so when you do a prediction with this model, there may be some improvement in the accuracy with respect to the previous model. Thanks again for the watching the video.